So next we go to the Bohr atom, and so one of the things that the classical atom failed to, apart from its stability, the classical Rutherford atom, it failed to explain atomic spectra. Okay, so for example, if you have some, say, gas of atoms, say hydrogen. So let me just, so suppose we have, sorry, we have some gas of hydrogen atom here, and you excite this gas with bombarding them with some particles, say electrons, right? And you can do that very easily by essentially filling up a vacuum tube with the hydrogen gas, and then allowing the vacuum tube be between a very high voltage, applying a very high voltage to the two ends of the vacuum tube, such that there's a breakdown of the gas, and so that there's a current that flows through the vacuum tube, and the electrons start hitting the hydrogen gas and exciting them. And then when the hydrogen gas relaxes, they give out electromagnetic radiation, and then this electromagnetic radiation is analyzed in a prism, and thereby you can find the spectrum of the atom. Now, what classical physics says is that, well, we have some fundamental frequencies. So, for example, if some atom has, say, so the hydrogen atom has one proton and one electron. So it should have some basic frequencies. So any radiation that is coming out should have a frequency which would be some kind of a harmonic of that frequency. Okay. So we have some basic frequencies, eta 1, nu 1, nu 2, etc. And these are positive integers. So the radiation coming out should be of this form. But it turns out experimentally, the frequency of the radiation looks very, very different. So for example, what happens is that the frequencies observed seem to be the differences of a set of numbers. So, for example, nu 1, 2 is T1 minus T2, and there's this set of numbers T1 and T2, and the frequencies that one sees seem to be made out of differences of these numbers. And not only that, they seem to, all these frequencies seem to have a frequency where they converge. So all these, the lines seem to, the spectral lines seem to come in some kind of a series, and each series has these very characteristic behavior where, so this would suppose is a spectral line, and this is a spectral line, this is one, this is one, this is one, and then they converge to a value. So there are all these different kinds of series of spectral lines, okay? So there are all these series of spectral lines. And there was no way classical physics could describe these things. Okay, so Bohr was able to solve all of these problems by proposing a model. And in 1913,